Hello, welcome back to Anatomy Lab. It's been a while. So today I plan to make a video of the appendicular skeleton of birds as represented by the chicken. And so we're gonna divide this video into two parts. First, the anterior appendage, basically the wings and the pectoral girdle that supports it. And then the second part will be dedicated to the hind limbs and the pelvic girdle that supports it. Starting with the pectoral girdle, this is the pectoral girdle of the chicken. So this is it. That dorsally, and the pectoral girdle of tetrapods are composed of basically two components: the scapula and the precoracoid or coracoid, depending on the species. Right? And the more dorsally located of the two would be the scapula, this sword-shaped structure here. And the more beneath it is the precoracoid in reptiles and birds. Okay. And then together they form this notch or depression here, the glenoid fossa, to which the humeral head articulates. So in an intact specimen, they look like this. So this is the rib cage, okay, and the thoracic region, and this is the sternum. This is the girdle. The one labeled R is the precoracoid. See how it is braced on the sternum. That's the left precoracoid. And then the one that is dorsally located is the scapula. This is the glenoid fossa. On the left side, you can see the humerus still articulated. Its head is articulated to the glenoid fossa. So the scapula and the precoracoid are cartilage bones, meaning they pass through a cartilage scaffold during development. They're categorized under the endoskeletal component of the girdle because there is a dermal component to the pectoral girdle. So dermal bones are bones that ossify directly from dermal mesenchyme without passing through a cartilage stage. And the dermal components of the pectoral girdle, typically the clavicles. But in birds, the clavicles, the collarbones, are fused together with the interclavicle, forming this structure here that you call the wishbone. This is called the furcula. So the furcula is formed by the two clavicles and the interclavicle fused together. These are dermal bones. Right? Scapula and the precoracoid are cartilage bones. And so I have here disarticulated wings. You're very much familiar with this if you're eating chicken. Okay, so this one is the upper arm bone, the humerus. And this would be the forearm bones. The thinner one is the radius, and the thicker one with the elbow is the ulna. And this one is the hand, basically the hand of the bird, but because bird forelimbs have evolved to become a modified structure, the wing, nag-fuse na yung mga finger or hand bones niya into this composite structure called the carpometacarpus. So let's examine them one by one, starting with the humerus, the upper arm. So this is the humerus, and that globular structure there is the head of the humerus that forms the ball and socket joint of the shoulder, and it articulates with the glenoid fossa, as I said. This larger bump here, if you notice, is the greater tuberosity, and then this lesser bump here on the other side would be the lesser tuberosity. If you look on the underside, there's a hole there, the pneumatic foramen. and it's located on the greater tuberosity. That's one way you can tell if this is the greater tuberosity, because underneath it is the pneumatic foramen. Because as you know, the bones of the birds have evolved to become pneumatic, meaning with lots of air spaces. They are hollow bones, which reduces weight baggage to be able to fly. Also, in the great lesser tuberosity, it forms a ridge more distally. That sharp ridge there is for the attachment of some shoulder muscles. This is called the deltoid ridge. Deltoid ridge. Okay. And then if you move distally, this is where the forearm bones would articulate. These are called the condyles of the humerus. Condyles. Let's move to the forearm bones. The thicker one, as I said, is the ulna. The thinner one is the radius. The ulna has a projection there, the elbow process, the olecranon process, more technically. Okay. And then moving more distally, this would be the hand region. But as I said, they have become fused. Lots of the hand bones have fused into a composite bone structure. This is the carpometacarpus. It's called that way because, guess what? It's formed by the fusion of carpal bones, the wrist bones, and the metacarpal bones, the palm bones. So in birds, there's a tendency not only for bones of the limbs to fuse together, but also to reduce in number. Right? So some of the digits, as you may be observing now, have been lost. You can only trace 3 fingers in a chicken wing, in a bird wing. The first, the second, and the third. The second and the third are typically fused together. Right? So basically, the bird only retained the first, the thumb, the second, and the third of its digits. Right. So the one you can see here in the carpometacarpus is a fusion of carpal bones plus the metacarpals of the first, second, and third. So metacarpal 1, 2, and 3. Plus the carpals, that's the carpometacarpus. And just to clarify. Now, moving on to the posterior appendage. So the girdle that supports the legs would be the pelvic girdle. And just like all pelvic girdles of tetrapods, the pelvic girdle is braced onto the region of the spine called the sacrum. But in the case of birds, as you should know, this region of the vertebral column is called the synsacrum. Okay. It's a synsacrum. It's made of a fused vertebral elements, not only the sacrum, but also some thoracic and lumbar elements, and also caudal elements. It's a synsacrum. And this is the pelvic girdle. So let's examine the subparts of the pelvic girdle. The topmost portion of the pelvic girdle, the one that is actually directly linked or articulated to the spine, is the ilium. And then if you move more ventrally, this portion is called the ischium. And then the third part is the pubis, the slender bone here, most ventral of the 3. Pubis. And then together they form this socket here for the femoral head, the acetabulum. There, the acetabulum. What's unique about the hip socket of birds is that it's perforated. It's there. It's a hole. Butas yan. Whereas in other tetrapods, their acetabulum are not perforated like that. It's unique to birds. And guess which other vertebrates have a perforated acetabulum? And surprisingly, the other vertebrates with a perforated acetabulum are dinosaurs, and extinct dinosaurs, linking modern birds today to the extinct dinosaurs. They are actually, by definition, phylogenetically, they are descendants of dinosaurs. Okay? And one common feature of them you can see in the bones, the perforated acetabulum. And there are plenty more synapomorphies of them. And so ilium, ischium, pubis. And then what other structures we can find? There are a bunch of holes beside the acetabulum. This one, between the pubis and the ischium, is the obturator foramen. Obturator foramen. The one more dorsal between the ischium and the ilium is the ilioischial foramen. Okay. And if you look underneath, you don't see a symphysis linking the left and the right halves of the pelvic girdle, do you? Right? Unlike in, let me get another pelvic girdle. Look here, I don't have a full pelvic girdle at hand, but this is a pelvic girdle of a mammal from a cat. And just imagine this would be the right half of the pelvic girdle, and the missing one is the right half. And this one would be the point of connection between the left and the right halves of the pelvic girdle. And they're connected by a fibrocartilage tissue, the symphysis, the pubo-ischiac symphysis. So typically in tetrapods, the girdles are linked together, physically linked together via a symphysis. But in the case of birds here, you don't see the symphysis, and therefore there's a wide gaping space in between the left and right halves of the girdle, and there's a purpose for it. It's birds tend to lay very large eggs, and therefore it was advantageous for them to evolve such a wide gaping space in the pelvic region. That's a likely reason for the absence of a pubo-ischiac symphysis in birds, so that they can lay large eggs. And so that would be it for the pelvic girdle. Moving more distally, the one that articulates to this hip socket is the femur. So this is the femur with some labels. Okay. So that ball-like structure is the one that fits into the acetabulum. That's the head of the femur. And the one being pointed by the arrow is the great trochanter. Great trochanter. And so this specimen here shows you the femur still articulated here to the tibiotarsus, the shank bone. So back to the femur here. So it's the head of the femur, the great trochanter. And then more distally, you have the condyles of the femur, where the shank bones will articulate. So let's move to the shank. So this is the shank. And the structure, the thickest structure in the shank would be the tibiotarsus. It's not the tibia, as in other vertebrates. Because guess what? From the name itself, you can deduce that this is formed by the fusion of the tibia and some tarsals more distally. So this fused structure is the tibiotarsus. Take note that this is different from the tibiofibula that you might have studied in frog anatomy. So the tibiofibula is the fusion of tibia and fibula. This one is the fusion of tibia and tarsals again. tibiotarsus. The fibula is not fused to the tibia. Okay, the fibula is still here. This splinter-like structure that's annoying when you eat chicken thighs or chicken legs. This one that is dangerous to swallow. It can puncture your throat. This one is the fibula, just beside the tibiotarsus. And there should be a small bone here, the kneecap, which is the patella there. So this is the tibiotarsus, fibula, patella. So the patella is what's called as a sesamoid bone. It ossifies from a tendon. It doesn't form from cartilage. It ossifies from a tendon. It's a sesamoid bone. Tibiotarsus has crests. Were there crests of tibiotarsus? And when you look, the proximal end of the tibiotarsus is called the condyles. The condyles of the tibiotarsus articulates with the condyles of the femur. So articulates sila, forming the knee joint. Condyles of femur, condyles of tibiotarsus. Then move more distally, which forms the ankle joint. This pulley-shaped structure is the malleoli. Malleoli. Okay. Then moving to the foot. So this is the foot, this is tibiotarsus, malleoli. This is the ankle joint, and this is the foot. And just like in the wings, the trend here is for bones to fuse. Previously separate bones to fuse and also to reduce in number. So this fused structure, you don't see the individual ankle bones anymore because they have fused to the tibiotarsus and also to the metatarsals. So parang nawala na yung individuality ng mga tarsal bones. Join forces na sila with the tibia and the metatarsal. So the fused structure here formed is the tarso-metatarsus, the Adidas part that we eat. Tarso-metatarsus. You see some digits here, whereas in the wings there are only 3 remaining. Here in the foot of the bird, there's still 4. Digit 1, 2, 3, and 4. The 5th one is missing. Those would be forming the digits would be the phalanges. Right. So where's the metatarsals? Again, it's already in the tarso-metatarsus. These are not the metatarsals. Phalanges already. This is tarso-metatarsus. And just a thing to point out here, so this is the ankle bone. It's formed between the tibiotarsus and the tarso-metatarsus. There's a technical term used to describe the position of this ankle bone present in birds. It's called intratarsal joint. It's called that way because it's located in between the tarsals. So you can imagine, wala na nga yung mga tarsals, right? They have fused proximally to the tibia and some fused distally to the metatarsals. So technically this joint is located in between the tarsals that have gone up and down. So this is an intratarsal joint. And I don't have a full whole mount specimen of a chicken here, but just imagine how a chicken stands on their 2 feet. They're bipedal, right? They stand like so. And so this kind of posture or gait has a name. It's called digitigrade. Basically, they're on their toes. They're tiptoeing. They're like that. As opposed to plantigrade, which would have been like that. So the chicken, the birds, stand on their 2 legs in a digitigrade gait. Right, so that would be for the avian chicken appendicular skeleton.